Hi guys, Mr. Mustafa here and welcome. In today's video we will be solving the June 2021 supplementary examination paper. Right, so suggested memorandum guys. Right, so this I will be making 4 videos on various topics. So the first topic is statistics, part 1 of 4. The second video I will make will be on after statistics is basically analytical geometry. Then after analytical geometry I will make a video which is part 3 on trigonometry, and finally Euclidean geometry. So there's only 4 sections in mathematics paper 2. Right, so see for the links in the description box. Right, so let us get straight into question number 1. Right, so question number 1, based on statistics, Sam recorded the amount of data in megabytes that she had used on each of the first 15 days in April. The information is shown in the table below. So on day 1, that's what it basically means. Right, so first 15 days. So as we can see, this data is what is it, the first 15 days. So day 1 of April, day 2 of April, day 3, right, and so on, right up to 15 days. So n is 15. We want the average for the data set. Now for the mean for the data set, you don't need to arrange this data in ascending order. Since they're asking for mean and standard deviation, look at the standard deviation, just 1 mark. So we can just use a calculator. How do we use a calculator? We can go to mode and stats. Right, so select option 3 and 1 variable data, and I've got x values. So enter all these values and we'll get mean and standard deviation. Right, so we have 26, 13, 3, 18, 12, 34, 24, 58, 16, 10, 15, 69, 20, 17, and 40. And hit enter and just see if I have got all the data properly. Just double check all of them. Right, so 26, 13, 3, I've got 18, 12, and 34, 24, 58, 16, 10, 15, 69, 20, 17, and 40. Right, so I have all my data. You can put your calculator on. Even if you put your calculator off, the data will still be stored. So what you do is you press shift and you go to stat, you go to var, which is 4, right, and select 2, the average. Right, select 2 and you get the average, which is 25. So x bar is equal to 25. So let's write it properly. Let's do the solutions here. You can say 1.1.2, 1.1.1 a, the mean. Right, the mean for the data set is given by this symbol, which is equal to 25, as we have found here. Now the standard deviation, right, standard deviation for the data set, standard deviation for the data set, we'll say on, right, shift 1, 4, and please use this one here, which is 3. Right, so sigma x, so standard deviation is option 3, and you press equals, we get 17,65. 17,65 is the standard deviation. So standard deviation, which is 17,65. Now remember, to get the variance we square the standard deviation, but we don't want variance, so you should get your marks there. 1.1.2, right, determine the number of days on which the amount of data used was greater than 1 standard deviation above the mean. Greater than 1 standard deviation above the mean basically means, let's use a number line. Right, so there's my mean here, which is x bar. I need to go 1 standard deviation above the mean, so there's my cutoff point here, which is x bar plus a standard deviation. So what's the value for x bar plus a standard deviation? There's 25 plus 1 standard deviation above the mean. Right, so we want 1 standard deviation above the mean. Let's add up those. So we're going to say 25 plus 17.65. Right, so we're getting 42.65. 42,65. So we want all the data which is above 42,65. So clearly not 26, not 13, not 18, 12, 58 is there. Above 42.65, right? So we want all the number of data above 42.65, because it means determine the number of days on which the amount of data used was greater than one standard deviation above the mean. Was greater than, what is one standard deviation above the mean? 42.65. So we want out of this, right? So greater than one standard deviation above the mean. Number of data, we're looking for number of data greater than one standard deviation above the mean is 42,65, right? Greater than number of data which is greater than 46.65 megabytes MB, MB, right? So let's see, 42, just 58, 69, can't be 40, right? So just two number of days, 2 days. Yes, so basically there's two number of, yeah, it won't be appropriate to say, just look for values, don't say this, you don't have to write this out, just say 2 days, it's fine, take this out. So we'll just say 2 days, because we have found 58 and 69 which is above 42.65. so determine the number of days, so 2 out of 15 days. So we're not going to say out of 15. They didn't ask for percentage of days. If they ask for percentage of days, you'll say 2 out of 15 times 100. Just ask for number of days. If they ask within one standard deviation, then you do x bar minus one standard deviation and look for all the values within, right? So we didn't ask for that. Now let's look at 1.1.3. 1.1.3, calculate the maximum total amount of data that Sam must use for the remainder of the month if she wishes for the overall mean of April to be 80% of the mean for the first 15 days. Okay, what's the mean of April? The mean for the first 15 days is 25. She wishes for the overall mean of April to be 80% of the mean. What is 80% of the mean? So 0,8 of 25, you get the new mean. All right, 0.8 times 25. Let's see, you say 0.8 times 25, which is equal, okay, I can clear the stats mode. I don't think there's any more questions based on this, right? So after this is a separate question, so let's clear the stats mode, otherwise you get funny stuff coming up. So 0.8 times 0.8 times 25, we got 20, right? So we want the total, so calculate the maximum total amount of data that Sam must use for the remainder of the month. So we have remainder of the month, we've got 30 days in April, so the remainder of the month we've got 15 more days, right? So how much of data must she use? So which is the overall mean? You want the total amount of data. She wishes for the overall mean of April to be 80%. Right, so total, see, the total mean is 20 for 30 days. So the sum of data, total data usage for April. So you're gonna say data usage for April is equal to 20 times 30, because 30 days, so you're going to end up using 600 megabytes, which is kind of funny because 600 megabytes just by watching one video you can use up every. Alright, so anyways, should have been used like gigs or something, been much. Alright, so it's fine. Let's see, 600 megabytes, maybe they use it for browsing, right? Let's see, 600 data usage for April is 20 times 30 is 600 megabytes. Now remember, we had for the first 15 days, what's the sum? If you subtract the sum for the first 15 days, we have the remaining 15 days. So remember, for the first 15 days your usage is some amount of data, and for the last 15 days we got, so in total you've got 600, right? So 0 to 15 to 30. In total, you've got 600. Now, you can work out the first 15 days because we have the average. So you can just say 15 times first 15 days usage. Right, so what was first 15 days usage? Total usage was 15 times 25. You can get that answer, which is 15 times 25, which is equal to 375. So 375, right? Therefore, this is 375, right? So that's the amount they used here. Who's this person here? Let's see. Who is this person? Right, so Sam used 375 megabytes of data. And now, what's the remaining? So, what did they ask us for? Calculate the maximum total amount of data that Sam must use for the remainder of the month. So, remaining data, right? Maximum remaining, right? So, max remaining, right? So, data usage can only be 600 minus 375. 600 minus 375. I think you should get 225 megabytes. Yeah. So let's see. 600 minus 375. 225 megabytes. Right. For the last 15 days. Maximum remaining data to use in the last 15 days, right? So in other words, maximum remaining, it's fine, just see how the wording is. So correct answer should be 225. Let's take this over, redundancy, right? Let's look at 1.2. Question 1.2. The wind speed in kilometers per hour and the temperature in degrees Celsius for a certain town were recorded at 4 for a period of 10 days. So at 4 o'clock every day they recorded for a period of 10 days. The information is shown in the table below. Determine the equation of the least squares regression line for the data. So 1.2.1, let me write in red. Okay, so y hat is, this here means estimated line, ax plus b. Right, so ax plus b, y is equal to ax plus b, so we want to get the value for a and b, right? Interpret the value for b in the context of the data. Should be ax plus b, right? Let's see. So we're going to enter all this data in the regression because we have x and y relationship, x and y, these are all coordinates. Now let's enter it in the calculator. Entering it in the calculator should give us, right, so go to mode, go to stat and select a plus bx. Oh, it should be a plus bx. Oopsie, should be a plus bx. Right, a plus bx is your least squares regression line equation. Right, so select option 2 and enter all your x values and the y values. So entering all the x values is 2, 6, 15, 20, 25, 17, 11, 24, 13, 22. Right, so we've got 10 data set. Now as I'm entering the y values, I will check all the x values. So 2 and 28, 6 and 26, 15 and 22, 22, 25 and 16, 17 and 20, 11 and 24, 24 and 19, 13 and 26, 22 and 19. Right, so I've got all my data set. Right, let me just double check everything. Right, so make sure all your data is entered correctly. You must always double check. Right, regression. So we have 28, 26, 22, 22, 16, 20, 24, 19, 26, 19. Right, so shift, we go to stat, we go to regression 5. Right, and select 1. It will give you the y-intercept, which is 29,35. So 29,35. 3.5. We don't know whether it's plus or minus. Let's see. So let's work out B. So shift 1, regress 5 and select 2, and the value for B is negative 0.46, negative 0.46, right, 46x. Now we have this. That's determine the equation of the least squares regression line for the data. So we've got the equation of the least squares regression line, 29.35 minus 0.46x. Remember, this value of negative 0.46 represents the gradient. It means that I will have a downward sloping line, a negative relationship between x and y. 1.2.2. Nice theoretical. Let's see. 1.2.2. Predict the temperature at 4 if on a certain day the wind speed of this town was 9 kilometers per hour. Wind speed is x, so 9 kilometers per hour. So we're going to say y is equal to, it's a prediction, right? So 29.35 minus 0.46 times 9. Okay, so I can exit this mode because I have all my data already. So what we have is 29.35 minus 0.46 times 9. Wind speed is 9, and what's the temperature? 25.21 degrees Celsius. 25.21 degrees Celsius. 25.21 degrees Celsius, approximately 25 degrees Celsius, right? Interpret the value for B in the context of the data. In the context of the data, the value for B represents, remember how we get the value for B. The value for B represents like change in y over change in x in terms of this least squares regression line. B is like your gradient. It represents change in y over change in x. So in order to explain this, we need to say for a unit increase, let's say for a unit increase in wind speed, for a unit increase in wind speed, right, for a unit increase in wind speed, the temperature, see the entire quantity, so the temperature for a unit increase in wind speed, the temperature decreases by 0.46 degrees Celsius. The temperature, right, decreases by negative 0, decreases by, not negative, decreases by, because we're saying decreases, so that's already a negative, by 0.46 degrees Celsius. So for a unit increase in wind speed, the temperature decreases by 0.46 degrees Celsius. That should make sense. Let's take this line out. Right, next question. Question 2. The number of days that grade 8 learners were absent at a certain high school during a year was recorded. This information is represented in the table below. Right, so number of days absent, 0 to 5, 5 to 10, 10 to 15, 25 to 30. Right, so these are all the number of learners absent within these intervals. Write down the modal class for the data. Modal class is most frequently occurring, right? So as we can see over here, that's a modal class. Most frequent is 98, and the modal class for this data, we just need to write it down. So it is 10 is less than equal to x is less than 15. Right, so let me just highlight the 98 to show you that's the most amount of frequency. So modal class is 10 to 15 days absent. Next one, that's 2.1 is sorted out. 2.2, how many learners were absent from school for less than 15 days? Less than 15 days will be from, how many learners were absent from school for less than 15 days? Well, this is from 15 to 20, so less than 15 days will be from here to there. So how many learners? 98 plus 45 plus 34. So how many learners were absent? calculate this. So 98 plus 45 plus 34, 177 learners. By the way, if you total this up, what do we get? 177. Did they tell us the total here? No, they didn't tell us the total. So if we do total this, we already have 177 up to this stage, right? We have 177 there, plus 43, plus 43, which is 220, right? 220 plus 7, 227, and plus 3, 230. So you're kind of working on the cumulative frequency. Remember, number of learners, that's a frequency. So the cumulative frequency, if you can just work it out one time, 34, 45, no, 34 plus 45. So 4 and 5 is 9, right? And then 3 and 4 is 7. So and 79 plus 98 should give us 170. So it's correct. Let's see. How many learners were absent from school for less than 15 days? So 177. If they ask us for the percentage of learners, we'll say 177 out of 230. They didn't ask us that. Right. How many grade 8 learners are at school? Just showed you total everything over here. So 2.3 total frequencies, right? So total frequencies, you will get 230, or you can work out the last value on the cumulative frequency. How many grade 8 learners are at school? All these, right? How many grade 8 learners are at the school? Now, draw a cumulative frequency Ogive to represent the data above on the grid provided in the answer book. Well, I don't have a grid, but to draw the Ogive curve, 2.4, to draw the Ogive curve, right? What we need here is we need the cumulative frequency on the y-axis, right? So we need upper class boundary and cumulative frequency, right? That's what we need. We need the upper class boundary and cumulative frequency. And to draw this, so let me draw this. So obviously let's make some space here quickly. Yes, then what are we doing? Use a cumulative frequency graph to determine the median number of days the grade 8 learners were absent. So we need to find the median afterwards. Okay, so let's see what intervals we can take. We can take intervals of 50s. We can go 5, 10, 15, 20, 25, 30, 300. Okay, well, we need a grid here. Let's see, let's draw it here rather. Yes, need a bigger curve. Right, so let's look at this. Draw a cumulative frequency graph. Now, when you're sketching the cumulative frequency graph, these are the points that we need, right? So there's the coordinates: upper class boundary and cumulative frequency. Upper class boundary, cumulative frequency, right? That's what we need. Those are all your points, right? So we're looking at 5, 10, 15, 20, 25, 30, and then it's going to be 5 and 34. And then 10 and 79, 15 and 177. So just checking what steps to do here. Should we take steps of 25 will be a bit difficult. So let's see. What steps can we do here? So if I go like this, go 50, 100, 150, nope, let's see, rather go 50 here, go 100, 200, 300, no, let's see, I can go 50, yeah, 100, yeah, let's just do this, 150, 200 and 250, right? And then 5, 10, 15, 5, 10, 15, 20, 25, 30 and 35. Okay, well, you see, in your case, when you're drawing this curve, you're going to get an exact answer, right? So I'm just going to estimate it because I'm drawing it kind of freehand, right? I'm just estimating values. So the first coordinate is basically the first coordinate is 5 and 34. First coordinate is 5 and 34, so we can go 5 and 34. I'm just estimating, guys, right? So 5 and 34, that's my first coordinate. My second coordinate is 10, 10 and 79. 10 and 79. 10 and 79 should be somewhere around, let's see, 10 and 79, somewhere around there. Next coordinate should be 15 and 177. 15 and 177. 15 and 177, that's 175 in between, just above there, right? 15 and 177. Then 20 and 220. We have 20 and 220, should just be around there. And then 25, looking for 25 and 227, just a little bit up. 25 and 227, and then we have 30 and 230, 30 and 230, yes, and we have 30 and 230. We don't have any 35s there, so we can take that off, right? And remember your ogive curve, we draw it in a different color. Take a red here. Alright, so is usually that S curve, kind of draw it freehand and then ground it to 0. Right. Sorry, we have 230. So to find the median, let's see, where's the median? 2.5. Right, so 2.5, 2.4. Now 2.5. 2.5, we want the median position. So this is, what is this? Class number of days absent. Remember to, this is a labeling, number of days absent. Well, they will give you this grid. Number of, and this is cumulative frequency on the y-axis. Now remember median position. Right, so all we can do is, for the median position, we take n and we divide by 2. N is 230, divide by 2 because we are approximating. So that should give you 115. So you'll go to 115 on your ogive curve, right? So this is around 115, so that's 125, so 115. I'm just estimating, guys, right? So 115 is somewhere around here. So it's between 10 and 15, right? So I'm getting an answer of approximately 12, right? So median position is 115th, right? 115th, and we read off Q2, right? So median is same thing as saying Q2. Therefore median, we always read off on the x-axis, so median is approximately equal to 12. Okay. Use the cumulative frequency graph to determine the median number of days the grade 8 learners were absent. Right, so then question 3 is on analytical geometry, so look for the link in the description box, right, and that will be part 2 of my video. Thank you for watching, guys. Don't forget to like, subscribe to my YouTube channel, and comment. Thank you.